Yeah, it's good to be back, isn't it? I'm super excited to be back. Anyway, let's talk about CI/CD and how to succeed with it. So, I imagine you've all been there, you've all shipped some software in your life. So, little thought exercise to begin with. Imagine you're getting ready to ship a piece of software, something you've worked on for maybe a few days, maybe a few weeks, hopefully not more than a few months. Sometimes that happens, sometimes it doesn't. But yeah, you've got everything done, right? Everything has been tested, everything has been reviewed, you've got the green light to ship, and all you need to do is press a proverbial big red button. So yeah, you press the big red button. It has a nice audible click, like a mechanical keyboard has. Tactile feedback. It's a satisfying feeling, isn't it? And then it's out of your hands. You've released the thing. You've unleashed the machinery. It's all happening. Software is being propagated to your users. And all you can do is really sit or stand in silence, maybe holding your breath, and wait what happens next. So yeah, then you've got two options. You can keep holding your breath until it's uncomfortable, nervously waiting to see if it's going to blow up, if users are going to start experiencing crashes, if you're going to have a really bad time trying to fix the mess that you just deployed, or pack up and go home because it's Friday at 4 p.m. and you've done your work, right? I don't know about you. I prefer option B. And the difference between the two, it really all boils down to automation, how much you have it, and how confident you are in what you have in place. And it always boils down to automation. I'm not talking only about software here. I'm talking about manufacturing. I'm talking about every industry that you can imagine. And yes, even something like agriculture. And this is not a talk about agriculture. I do like to still compare the processes with CI/CD and how software is actually being deployed. So yeah, imagine you've got this field. You're growing something on it. Let's say it's hops, because I like beer. You can do everything manually. You can have dozens of people planting everything, picking everything, watering, weeding, doing everything you do with a field. Or you can invest in some machinery, maybe get some tractors, maybe get some irrigation systems in place that allows you to do more with less and achieve also more predictable results. Obviously, you can take this a few steps further, or a few dozen steps further, and invest in this high-tech greenhouse that controls everything to the last possible variable, like humidity, temperature, air that you're supplying, light. I imagine there's also irrigation systems that kind of pumps to each individual plant exactly the nutrients it requires. And I do like to imagine that these awesome robot hands use computer vision to pick up the plants, the crops at their ripest, so you can actually sell them for the highest possible profit. And that, my friends, is what a really finely tuned CI/CD pipeline does to your software, to your application, to whatever you're building. And of course, that's all fine and great and awesome, but sometimes it doesn't work quite like that. Sometimes machines misbehave. Sometimes they don't do what we want, and they can definitely ruin your crops, those robots. They probably won't rise up into giant dinosaur things and bring us back to the second Stone Age, hopefully, anytime soon anyway. But your automation can at least ruin your crops or ruin your day and your users' day. But yeah, never fret. It's never the machines, it's always us. And because we program the machines, we set them up, we configure them, and everything is actually our fault. Good. I'm Zan, by the way, and it's often my fault. Yeah. I'm a developer advocate at CircleCI, and this is a talk about CI/CD success with Android in particular. As I mentioned, I work at CircleCI. Who's heard of CircleCI, by the way? A lot of people. Good. Awesome. We can skip a few slides. Who's using CircleCI? A few people less, but good still. Anyway, yeah, we're the leading CI/CD platform. We allow developers everywhere build whatever they're working on, empowering teams in various industries. Anyway, one of the big fields that we support is Android, so DroidCon. Anyway, for those who haven't heard of CircleCI or who've not been introduced to CI/CD, let's quickly go through this. It's a double acronym, CI/CD, where CI stands for continuous integration. And it's what happens when you automate all those build and test processes that you can do either like manually when you press build in your IDE, or you run some software that is through continuous integration automated. So the things are run whenever you are pushing a commit to your repository. So you get instant feedback whether your software is working, whether your tests are passing, whether something like a static analysis has been satisfied or not. By the way, Nico is having a talk right now about detect in Kotlin, which is pretty cool. So you can do things like that as well, not just running your unit test, not just running your instrumentation tests, whatnot. You can also do security scanning and so on. But yeah, the idea is this happens automatically. It's tied to your process, so you're pushing your commits, you're running all of this automatically. And one more important thing is everything happens in isolation. So these jobs, these pipelines, they are executed on either Docker containers that are spun up just when you request them, or virtual machines, or again, whatever you want to run this on. But yeah, you have a clean environment that you always kind of set up from scratch. And it's all configured through code tied to your exact commit. So if your commit hasn't changed, which it hasn't because it's kind of locked into space and locked into time and space, obviously, your pipeline will always produce the same result, which is good because we have some reproducibility. That's the CI part of this. CD part of this is continuous deployment. And this is what just the name suggests, getting that software that you just built into the hands of your users or whoever needs to have it. It could be your testers, it could be your stakeholders, it could be, yeah, whoever, wherever this needs to be. And this is not only Android specific. This works for any type of software. This works for websites. This works for microservices, Kubernetes deployments, infrastructure even. You can do anything, and the principles are pretty much the same. But yeah, it's basically running a set of scripts, one after the other, to get that software where it needs to be. So yeah, that's CI and CD. And yeah, that's quite a lot of things. We're doing all the testing, we're doing all the building, we have multiple environments, maybe even multiple devices that this can run on. For example, if you're doing an automotive app like Juhani and Pierre were talking about this morning, like that can also be kind of automated in this way using CI/CD. And yeah, as you can imagine, this is a lot. So we've kind of decided to break this down into multiple dimensions that I'll be covering in this talk today. So yeah, let's start. First one, when people think about CI/CD and succeeding with it, is usually something related to speed. How quickly do you get the results back from your tests that are run automatically? Because that's your feedback, that's how you know that your things are working as intended. If you've been to Alex's talk yesterday about feature flags. So that was like, he's basically mentioned the importance of getting like really rapid feedback from your test that you're running, so that you can actually do like things like trunk-based development and so on. But yeah, whether you're doing that or whether you're doing classical branching model, still speed is important because you want to know as quickly as possible whether your stuff is working or not, and whether you have your application that you can then give to your testers, to your stakeholders, to your product manager, whoever. But speed is much, much more than just running a pipeline. Speed is much more. It's also things like recovering from a build that actually fails. So if you're thinking about your repository, you've got your main branch or master branch, and you might have like feature branches. The idea is that your main branch is always the one that's kind of that has software in a working state, that's in a shippable or releasable state, and that's what your CI/CD system gives you. So if the tests aren't passing on that main branch, that's a problem, right? So you really want to reduce the time to get from red back to green, green meaning successful or passing build. So that's another aspect of speed that's very important and very important for your success in a CI/CD pipeline. I've seen horror stories where we couldn't get it back from red to green for like 2-3 weeks. It wasn't pretty. Team was starting to argue all the time, and yeah, it's just important to always kind of get back into it. It's also things like organizational time to ship something. Your product manager gets a mandate for a new feature. Maybe you're working on something. How long do you need to go from this beginning of conception of this feature to actually getting that to your users? That's another aspect of speed. CI/CD can help you reduce that time, because you can ship smaller increments. You can automate a lot of your tests so that they happen faster, earlier, and so on. So yeah, you can focus on deploying and developing the value for users. And also things like onboarding a new team member. So if you've hired someone, you probably know that it takes a while to actually get acquainted with the application, regardless how many modules you have, how big the application is. It always takes some time to kind of get someone in. If that person is a contractor, obviously you want that time to go as quickly as possible. If it's a new team member, still it's important. But because everything we do in CI/CD pipelines, we configure everything in code, you can basically just point a new team member to that configuration and essentially tell them, hey, read through this, you'll understand which tests are being run, how we're running them, where we're actually deploying this, to which environments. At CircleCI, we use YAML. I am not the biggest fan of YAML myself, but it's a format that's readable both by humans and machines. So it's like quite easy to go through it and understand what's what, and then that person can actually go to you with new questions and understand what's what. So yeah, let's dig into the first aspect of speed, to run your pipelines faster, run your tests faster. First, most important thing is use the resources that work, that make sense for your application or your system, your piece of software. That means give it enough RAM, give it enough processing power so that Gradle doesn't take 20 minutes to build, because I think a good rule of thumb is if you can run something on your laptop in like 3-5 minutes, and then your CI takes 10-15 minutes to build the same thing, maybe that CI is really underpowered in terms of resources. If you're using a cloud-based solution, you can actually just kind of up the resource class or whatever you're allocating, and that's gonna usually make it faster. Speaking of doing things faster, it also helps to deduplicate your work, and we do that by caching things. So Gradle has a cache many other build tools, whatever you're building, have some kind of cache for dependencies, for artifacts, intermediary stuff that gets built. So you can actually cache those. For example, my favorite example is node modules. I know it's not Android related necessarily, but if you've installed a node application, you kind of get write the npm install, and that kind of downloads a ton of stuff, a ton of dependencies. If you do that each time, that obviously can take maybe multiple minutes. And by using cache, you basically store those dependencies and just check whether your dependency declaration has changed. So if any of the versions have changed, you would get the new ones. But if not, then you can just use what you had in cache. So that saves you minutes, possibly, to not just having to download everything. Next one, speaking of cache, actually you can also cache things like artifacts. So you build your app and then you want to run some tests on it. So just build it once and then reuse that same app, pass it to the subsequent jobs, subsequent parts of your pipeline that then kind of help you not do that kind of build process again, if you can. You can also do things like running in parallel. So jobs, for example, if you have unit tests, integration tests, functional tests, all different types of tests, security scans, static analysis, you can actually just do kick this off like at the same time, and then instead of running them one after the other, because you just want the results, and the sooner something gives you results back, the better. And you can also split tests, which is another really, really cool feature. So, so essentially, if you have a very long-running test suite, we once had like 300 functional tests in an application. That was way too many, but we didn't have this parallelization in place. But if we were able to like split those this single test job into multiple ones that run in parallel, each one would take maybe 10 or 30 tests. We could have 10 jobs, split those, and get the results back in 1/10 of the time. So instead of 3-4 hours, we'd get it in a lot less time than that. So you can do that. Splitting tests is super, super important and super cool, especially if you have long and extensive test suites. And you can also think about what needs to run. So maybe you want to run unit tests every single time, but maybe you don't want to run your extensive test suite that checks integration with various other systems all the time. You just want to run it on a pull request or at a new tag that you kind of prepare for a release. So really think about what needs to run. Maybe do some nightly builds that kind of take this off your kind of standard development flow and give you results with some lag, because obviously it's a nightly build, it runs afterwards, and you get the results in the morning, but still it saves you time so you can move faster and have more fun doing it. So yeah, you've probably heard about this thing, Ever Given. It's a ship that got stuck in the Suez Canal. And yeah, it's my analogy for a failing main branch. And yeah, when something like that happens, it's super important that you really get onto that, fixing it as soon as possible, because no one could actually pass any cargo through the Suez Canal, which is one of the most important waterways in the world for everything that you buy, basically, everything that kind of comes from China to Europe, and that's a lot of stuff. All your phones, by the way, were kind of stuck waiting for that ship to be removed. So yeah, that's your analogy. So yeah, if we have a failing build, how do we do? How do we know what we need to do? First off, we need to understand what's happening to our builds. So that's like every tool will be different, but everyone will give you some ability to check what's happening, where the failure is. So you want to pinpoint that and understand, yeah, it's my tests failing, or it's my orchestration stuff that's failing. It's another script. It's, yeah, whatever it is. Understand what's happening so you can focus on fixing that problem as opposed to just triaging this thing for a while. Logging helps. So whatever you're doing, again, have an ability to log as much as possible, understand your logging tool, understand your build tools, and just like understand how you're actually gonna turn on the verbose logging mode, the debug mode for whatever you're doing, so that you get that results as quickly as possible, helping you get that triage done and understand what you need to do for fixing it. Sometimes you get the logs and they're all in that kind of web interface of your CI tool, which is good, but sometimes you want to get those logs out, so you can use grep, you can use more advanced tools to actually get around those logs and analyze them. So understand how you're actually going to get those logs out is another skill. It's another trick that you can just have in your toolkit, which will definitely save you a lot of time, allow you to be more successful. Same with build artifacts, so get that app out. Maybe some of the functional tests are not working. Try it out yourself on a debug build. See what's happening. So understand how you're going to get that out is super important. And probably my favorite one is the ability to debug builds as they are failing. As I said, builds do happen in isolation, so in a Docker container, for example. But like with Circle, we have the ability to SSH into that running container as it's kind of failing your build. So you actually are in that environment. You can explore through command line what the state of the build is, and then kind of that helps you get to the root of the problem faster. Now, you still need quite a lot of work to do, but you've been able to triage your issue hopefully a lot faster and understand what you need to do to get from failing to green. So that's the speed part of things. So let's continue. But obviously, I know I opened the speed section with Formula One cars, which is wrong to think about a CI/CD as a race car, because it's not really a race, you know. I do like the ambulance analogy much more, because it should, of course, go very fast as possible, but it also needs to carry the signal of your application, of the state of your application, so that you need to have enough information about your app, about the tests that you've run, so that you can actually be sure that your work has been successful. So that payload that you're carrying in your kind of CI/CD ambulance is the signal, and that tells you of the quality of your app. So when you see the lights flashing, if it goes red, go fix it ASAP. So that was speed. This is from one of my favorite games ever. It's from Monkey Island, The Secret of Monkey Island, the first one. Absolutely amazing game. Basically you get caught by these cannibals, and they put chains and more advanced locks on your gate, even though you kind of keep escaping through a hatch in the door, in the floor. But so that's our analogy for security. How do we get the most secure application from our CI/CD tool? How do we use it for that? First off, the most important thing, and what you should never ever do, is don't keep any credentials in your Git repositories, because if they're in there, they are leaked. You can consider them compromised. And again, that could be your Play Store credentials, that could be your AWS deployment credentials. No credentials are safe if they're in the Git repository. Your CI tool has the ability to inject any variables at the time of the build or test or deployment. So you can actually keep them encrypted and inject them whenever you actually need them. You can also split them apart. Like at Circle CI, we have this thing called contexts. So you can actually split them based on who the user is, what kind of activity you're doing. Maybe you're doing a deployment, maybe you're running a static code analysis, and you don't need that deployment credentials, but you may need some other tool. Maybe you have a deployment to various different app stores. Maybe you have You have keys to interact with different environments that you have, so you can actually split those based on where you're actually, what you're actually doing with your app, and that's really good practice. And that also allows you to set up some privileged access. Maybe you only want a certain senior team members in your team access to actually deploy something, but limit that access to graduates or more junior members. Or maybe you have you work with an enterprise and it's more like you have a delivery lead who's responsible for deciding whether something can go or not, and that person has that privileged access to do that kind of privileged activity, like deploying something. So that's something you can always think about implementing, and it's really gonna save you a lot of time, and obviously also money, because security, compromising on security is never a good idea and always kind of comes back to bite you whenever you're least expecting it. Third thing you can do and should be doing is automate things like security scanning. So you're pulling in all those open source dependencies, that's awesome. But what if someone has actually compromised one of the dependencies? So we've seen that in the web world especially. We've seen British Airways, for example, leaking all customers' passport data and so on because they've kind of pulled something in from an unsafe NPM package. And there's a massive lawsuit going on right now, and that's something you can avoid by using, for example, a tool like Sneak to integrate security scanning into your flow. So you have a security scanning job as you would have a test job, which then checks your dependencies, checks your application, and tells you, hey, your dependency on, I don't know, whatever is either has a known security vulnerability, you should fix that before we can actually allow you to pass your build. So yeah, now we've kind of covered speed, we've covered security. Let's look beyond. What I mean by that. So first off, if you're thinking about your CI tool and you have it in place, you have everything configured, maybe there's something you could actually be using that the tool has that we've released that you're not aware of that could actually save a lot of your time. For example, that SSH debugging or whatever new feature is being released. That could save you a lot of time. So it's good practice to just kind of go through release notes every few months and just kind of like understand, hey, we implemented this 2 years ago, but now we have 4 new features that can actually save my team a lot of time or make my team a lot more successful. Maybe you want to think about integrating with external services. For example, your project management tool, your dashboards that your ops team is looking at to kind of analyze the safety and health of the system. So really kind of understand whether there's opportunity to get the information about your builds somewhere else. So maybe your product manager wants to know, hey, we've deployed this, and they won't have to go talk to your team about this. Hey, have you actually done this? Maybe you can just update that Jira ticket automatically when you've actually done the deployment, which is really, really cool. Again, whoever else needs to know. Is it an ops person? Is it the delivery lead? You can Slack them, you can page them, or just like understand that there are ways to kind of get the information about your builds somewhere else or to whoever is relevant. And yeah, it's never a DevOps talk without talking about a team. And CI/CD is always and should always be a team responsibility. If you are the only person who wants to be tinkering with it, please, please, please do spread that knowledge across your team as well, because if you go on vacation, if you leave the team, that team is going to be screwed if you only have one person who's responsible for everything. There's also a virus going on, if you've heard, that can leave you out of commission for a couple of weeks, or worse, hopefully not. Anyway, yeah, spread that knowledge, help everyone understand what's going on with your builds, which is which is helpful because, again, it's an onboarding aid as well, and everyone can understand, yes, these are the environments, this is what we're doing, and yeah, use that to kind of really widen the understanding across the entire team. So yeah, now, everything that we do, even if we followed all the best practices, if we have all of the cool stuff in place, sometimes, somewhere, a broken deploy will still get through. And the last thing we need to do is understand how we're actually using a CI to revert that broken deploy as quickly and efficiently as possible and as painlessly as possible. Because yeah, you will ship something that doesn't work. You will ship bugs, you will ship something that crashes. It happens, we're humans. It's just the nature of things. So yeah, CI can definitely help you enable fast recovery and reverts because, as I said in the beginning, everything is tied to a commit. You can just revert back to the previous commit and run the pipeline again, and maybe, hopefully, that's enough to get your application back to the state that was fully functional without the bugs. You can also, by relying on CI for releases and deployments, it will automatically help you favor smaller increments, smaller changes, and obviously smaller changes, smaller chance to ship something that's terribly broken. It can just be a little bit broken, maybe. So yeah, the best way to do something like that is to have a plan in place. And again, every team is different. Every team will have their own processes, just like encode this, write this somewhere. Maybe not in a CI/CD pipeline, maybe in there. You can still use the comments in code like that. But yeah, just have a plan in place, understand what needs to happen, if we need to revert something, if we need to fix something, and do a practice run every few months with the team members to kind of understand, hey, that's what we're going to do. Let's pretend we shipped something that's broken, follow the checklist. You'll find that not everyone is aware of the plan. Maybe you'll find that plan has some steps that are obsolete or that should be changed. So yeah, it's really good to kind of still be practicing how you're actually going to be doing the reverts. All in all, to me personally, having a really good CI/CD pipeline is, yeah, like having that really awesome automated greenhouse. But most importantly, it means to have the freedom to actually be focusing on the software that you're working on, your craft, and really deliver the software on the terms that you want, on the terms that work for your teams, that help your team be successful, and yeah, let you focus on quality, team happiness, and yeah, it will allow you to adapt to change faster. It will allow you to have this self-documenting build, test, deployment process without losing any of the keys, without this kind of hectic run around whenever we want to ship some new changes or, yes, recover from failures. And yeah, that's kind of all I have today for you. I hope you've enjoyed this. I hope you've learned something. I do have slides available on this link. And if you want to get a t-shirt, just like follow that link, fill it in, we'll ship it to you. We don't have any on us right now, but yeah, if you've got any feedback, questions whatsoever, circleci.com/Zan is that link. You can get it. GDPR compliant, obviously. So don't fret. It's not going to be entered in a drip campaign. But yeah, is there any questions or something?